Okay, here we go. Okay, guys, welcome back. Day 2, week 3. Remember to leave an empty space at the top, and then you place the date, which is September 7th, 2021. Okay, so remember you need to place it over here, right corner. So today, before we go into any further exercises or anything, there's certain things that we need to define, okay? Because the definitions are what is going to help us, or what are going to help us, okay, sorry for that, understanding the exercises themselves and solving and simplifying them at the end, okay? So all of this, remember, you need to copy them in your notebook. Okay, so we got a variable. Do you guys remember what a variable is? You remember what a variable is? Anyone? We worked with this a lot last school year. So what is a variable? What do you remember a variable is? Remember, there are no wrong answers. It's just your participation. So what is a variable? Come on, what's a variable?
It's a letter that stands for a number.
Exactly. It is a letter. It's usually a letter, okay? Usually, because sometimes it is not just a letter. Sometimes it's something else, okay? But yes, we're going to say that it is a symbol. A variable is a symbol, usually a letter, that represents or that stands for represents a number or an unknown number. Okay, that's the variable. It is a symbol that usually represents an unknown number. And it could be anything, okay? It could be any letter. So for example, it could be X, it could be Y, it could be E, it could be L. But like I said, sometimes it's not a letter, or at least not a normal alphabetic letter. Sometimes it's a symbol. Sometimes it is theta. That's supposed to be theta. Sometimes it's theta. Sometimes it's phi. This usually represents angles, okay? Yes, Naomi. So that is a variable, okay? Now, what is an algebraic expression? We saw already what a variable expression is. We saw that a variable expression is a mathematical phrase that includes variables, numerals, and operation symbols. Okay, in this case, it is basically the same thing as an algebraic expression. So an algebraic expression is a mathematical phrase. Also, it's a mathematical phrase that can include numbers, variables, and operation symbols. Okay. Sometimes they're also called variable expressions. So they're basically the same thing, okay, because they're sometimes called variable expressions. Okay, so an example of that, it could be 2x. It includes a number and includes, yes, it's an exercise. It is 2x, it includes a variable and a number. It could be, for example, 3y minus 4. It includes two numbers, one variable, and two operations, okay? The multiplication and the subtraction. Or you can even have x minus 4, sorry, x minus 4 over 3, or over 3y. So you got two variables and 3 different operations, okay? So that is a variable expression. Now, we have another definition that we need to remember, and it is an equation. Do you guys remember what an equation is? You guys remember what an equation is? What's an equation? It is this is a mathematical sentence, not a mathematical phrase, okay? It is a mathematical sentence because in math, we have also sentences, okay? It's a mathematical sentence that uses what? An equal sign. So if you see an equal sign in an operation, then you need to remember that that is an equation. 2x equals to 1. That's an equation. 3y minus 4 equals to 10. That is an equation as well. We have different types of equations. Sometimes they can also include exponents, okay? So that is an equation. Now, what's an open sentence? An equation that contains more than one variable. Okay, Dixana, thank you. Okay, one or more variables. That's an open sentence, okay? So an open sentence is an equation that contains one or more variables, okay? So, for example, and we're going to get to see this as well. For example, 3x plus 1 equals to y. This is an open sentence. Or, for example, z is equal to 2x squared plus 3y. Okay, it has 3 variables. This is also an open sentence because it has one variable, okay? So if it contains one or more variables, we're going to call it also an open sentence. So equations are open sentences, okay? Those are the first 4 definitions. Now we're going to talk about the definitions that are in an equation. All of these are part of an equation. A term, a constant, a coefficient, and like terms, okay? So that's what we're going to define now. And we defined this last school year again. So a term is a number, a variable, or the product, meaning the multiplication, okay? Or the product of a number and a variable. Or we can say, and one or more variables. Okay, so that is a term. An example of a term, someone is telling me over here, an example of a term is negative 4x cubed. Yes, awesome. That is an example of a term. So I'm going to give you several examples right now of terms. So just like the one that they gave me on the chat, negative 4x to the cube. This is a term, okay? Also, 1 for any number, okay? Let's say, instead of 1, let's say 10. 10, any number, or just a variable, n. Or the product between one or more variables. Also, for example, 5x squared y cubed. That's a term as well. So everything that is just a single part made up of a number or a variable with exponents, or just a variable or the multiplication between them, that is a term, okay? Now, from that part, from a term, we have also different definitions. A term can be a constant. And what is a constant? A constant is a term that has no variable, meaning just a number, okay? So any number is just a constant. So it could be -5, for example. It could be +11. It could be -1. It could be +1. All of those or any other number that you can imagine, let's say 1/2, that's also a constant, okay? Because it is just the number, okay? Now, a coefficient. A coefficient is a numerical factor or a number of a term that has variables. Okay, so the coefficient, I'm going to place it in a different color. For example, we got 3x. So the coefficient is the one in blue. 3x, 3 is the coefficient. Or for example, -y. What is the coefficient of -y? What's the difference? What's the coefficient of -y? Anyone? What's the coefficient of -y? Come on, I know that you can tell me the answer. What's the coefficient of -y?
Imaginary one.
An imaginary one, Daniel, that's it. An imaginary one, but with the negative. So the coefficient of this term is -1, okay? It could also be -25. -25 will be the coefficient of the term -25x to the square, okay? So that is the coefficient. The number right next to the variable with the sign that it has in front, that is the coefficient, okay? Now, the last definition that we're going to see right now is like terms. Someone in the chat was saying that they have the same variable and powers. So yeah, kind of, okay? So we can say that like terms are terms that have exactly the same variable factors. Meaning same variable with same exponents. Or constants with constants. Okay, so for example, if I have -4x plus 3y minus 5 plus y. And we're going to identify the like terms. So do we have a like term for -4x? No, because there's no other variable that has an x. Do we have another like term for 3y? Yes, we do. Which one? Positive y. Do we have a like term for -5? No, we don't. So the only like terms that we have in this exercise is 3y and y. Another example, let's say 3x to the square plus x minus 2x squared minus 5 minus 2x plus 11. Okay, so we're going to find the like terms of this. Do we have a like term for 3x squared? You will?
2x squared.
Negative. Remember the sign. It has to be taken into account. Negative 2x squared. Do we have a like term for x only?
Negative 2x.
Exactly. Negative 2x. Do I have a like term for negative 5?
Positive 11.
Positive 11. And why do we need like terms? Because like terms are going to help us simplify the exercises, okay? Now, that's another definition that is not included on this side. So we're going to include it over here. What is a simplification, or what does simplifying means? What does simplifying means? It means to add or subtract according to the sign, okay? All like terms in order to have no more like terms. Okay, so that's simplifying. Okay, I know it sounds kind of crazy, but simplifying is adding or subtracting according to the sign of the terms, all like terms in order to have no more like terms. Okay, so let's copy the exercise that we had over here, down here. I'm going to copy this exercise. I'm going to place it over here. And we're going to simplify this. Okay, so you can see we had two terms that had the x squared, two terms that had the x only, and two terms that were only constants. So we're going to simplify them. And there are different ways of simplifying them. The last year, we simplified them by writing an extra step in which we rewrite the terms one next to the other when they are like terms. So we said last year, negative 3x squared minus 2x squared. And those were the first like terms. And then we had positive x minus 2x. And those are the next like terms. And at the end, minus 5 plus 11. And that's what we did last school year. And we rewrote the algebraic expression with the like terms next to the like terms. But now we can do this, or we can go and skip the step. Remember that I told you that this school year, we're going to start skipping step, okay? So we can skip that step and we can just go ahead and say 3x squared minus 2x squared. Okay, so remember, when we are simplifying, we add and we're adding and or subtracting, like this is the case, we are going to add or subtract the coefficients and copy the variable with its exponent once. So we're going to say 3 minus 2, that's 1, 1x squared. Now remember what I told you last school year. We do not need coefficients 1. So I'm not writing that. I'm just saying x squared, okay? Because I'm not using that. Now, positive x minus 2x. Remember, there's an invisible one in here that I do not need to write it. I'm just placing it right now so you can remember. And then I'm going to subtract. And using those the rules of signs, different signs, I subtract and I keep the sign of the greatest number. So it is negative 1x. So it's going to be just negative x. Then negative 5 plus 11. Again, loss of signs. I subtract and keep the sign of the greatest number. So that's going to be plus 6. And this is the simplification of this exercise, okay? So remember, when we're simplifying additions or subtractions, like terms, you add the coefficient and you copy the variable with the exponent once. Let's write that as a little tip, okay? We're gonna write it in pink. And we're gonna call it tip. Just for you to remember, okay? This is something that you know already, but I'm just giving it to you so you remember again. Okay, so when adding or subtracting like terms. Okay. I put here simplifying, adding, or subtracting. Sometimes it could be multiplying or dividing. Okay, but I'm just going to say add or subtract. So when adding or subtracting like terms, we add coefficients and copy once the variable with its exponent. Okay, and I can only do this with like terms. I cannot do that with a different term. So I cannot do this subtraction and say that this is 0 or say that this is x because they are not like terms. Okay. No, that is for divisions. Okay, this is for division. What you're telling me here, that's division of exponents. But now we're adding like terms, okay? Remember, they have same basis. We are not multiplying same basis. We're not dividing same basis. We are subtracting terms that have the same variable and the same exponent, okay? They're different. You're going to be able to identify it in a better way when we start working with exercises, okay? So don't worry. So that's the tip. When we add or subtract like terms, we add the coefficients and we copy once the variable. And when I say we add, we take into account the sign. So we could be we add or we subtract according to the sign, okay? Just like in this case. This was a subtraction, but this could have been a positive, so it is an addition. So according to the sign, we add or we subtract. Questions so far? No questions. We are good with this part of simplification of like terms. Yes? Okay, now I'm gonna give you another example of the simplification when it is not an addition, okay? For example, this means that this is in another example. We have 7 parentheses t minus 4. Okay, and we are going to do the disparity property. 7 times t and 7 times negative 4. 7 times t, since they are different, one is a constant and one is a variable, you just go ahead and copy them and say 7t. Now, I got 7 times negative 4. I take into account the sign. Positive times negative, negative. And 7 times 4, 28. And this is also simplification, okay? This is also simplifying the expression because we're using the disparity property, okay? It is to give it in the simplest form. It is to leave it in a form in which you have no more like terms, okay? That's what it means simplifying. It's not just adding or subtracting, okay? It's just to live an expression with no more like terms. So let's change that. Let's change that, okay? Let's change this. Living an algebraic expression with no more like terms. That's what we're going to see. Living an algebraic expression with no more like terms. Using the operations needed. It could be an addition or a subtraction. It could be a multiplication or it could be a division, okay? So let's change that. Yeah, I know, I miss, but I know. Okay, let's change it, okay? In that way, we are enclosing every single operation in the simplifications. And that's okay. Questions? No? Okay, I'm going to do another one. I'm going to do another simplification. I'm going to say, for example, we're going to have different things. I'm going to say, for example, negative parenthesis 3t squared plus 2 plus t parenthesis 2t And that's it. That's it. I'm gonna leave it like that. So now remember, this negative sign is like you had a -1, okay? It's like you had a -1, but I'm giving you another little tip. And we're gonna call here, place it over here so we can know that other tip, what that tip is about, okay? So we're gonna say number 2 of the tips. When there is a negative sign outside a parenthesis, it is basically using the security property okay? It is basically using the security property. So we are just going to change the signs of everything inside the parentheses. So what am I talking about here is that instead of doing the security property, -1 times 3 to the square, -1 times 2, I'm just going to change everything inside the parentheses. And this is going to be 3t squared is positive. Now it's going to be negative 3t squared. 2 was positive. Now 2 is going to be negative. Okay, and I finished with the first parenthesis. Now I do need to do the security property over here. You can see those are same bases and we are just multiplying t times t. Okay, and this has an exponent 1 and this has an exponent 1. And according to the rules of exponents, I need to add the exponents. So this is going to be plus. I copied a 2 because the 2 is not a like term. It doesn't have nothing, another number, so I cannot multiply it or anything. And I just go t times t squared. But I haven't finished simplifying because I still have like terms. I have this and this that are like terms. So I can simplify that. Negative 3t squared plus 2t squared, that's negative. Different signs I subtract and I keep the sign of the greatest number. 1, which I don't need. And I copy the variable with the coefficient 1 time. And since the -2 has no like terms, I copy -2. And that's it. Basically, that's everything that we're going to see today. So let's place the name of the topic. Okay, let's move this a little bit to one side and let's place the name of the topic. What is the name of the topic? What do you think is the name of the topic? Introduction to what? That's an introduction to what? Or what are we doing? What did we just do? What did we solve in there? Or what did we solve? Or what are we introducing?
Simplifying algebraic expression.
Okay, so we're gonna call it algebraic expression. Instead of introduction, we're gonna call it algebraic expressions. And that is today's topic, algebraic expressions. Because after that, we're going to get into equations. But first, we're going to work in algebraic expressions. Any question about this? Okay, then, this is the topic for today.